we'll be looking at another aspect in continuity equation, right? Which is continuity equation in Cartesian coordinates, right? Now from here, continuity equation, we look at what continuity equation means itself. We said by definition, what is continuity equation? We said continuity equation is based on what? Conservation of mass, right? Meaning that if no fluid is added or removed across any length of your section, then the mass remain constant. We've defined that. We've looked at what continuity equation means. But today we'll be looking at continuity equation in Cartesian coordinates. How it works here is that, by Cartesian coordinates, mathematically, we have this is x axis, this is y axis, and this is what? Z axis. So the idea here is that we are assuming, or we are saying that there's a fluid component in the x axis, there's a fluid component in the y axis, and there's also a fluid component in the what? Z axis. There's a fluid component in the x axis, in the y axis, and in the z axis. Now we are going to denote these fluid components in each axis respectively to be what? U, V, and W. Before then, we said we have two types of fluid, right? We have compressible fluid and incompressible fluid. For today's class, we'll be looking at Cartesian continuity equation in Cartesian coordinate with respect to incompressible fluid. Meaning, we'll be given an equation. The question will now say that verify if this incompressible fluid satisfy continuity equation. Again, I'm saying the same way we have for incompressible fluid, we also have for what? Compressible fluid. But for today, we'll be looking at what? Incompressible fluid. Now, as I said earlier, I said given a Cartesian coordinate, say x, y, and z, we are going to say that we have at each axis, we are going to say that we have fluid component flowing through x axis, fluid component flowing through what? Y axis, and fluid component flowing through what? Z axis. Fluid component flowing through x axis denoted as u. The fluid component flowing through y axis denoted as v, and the fluid component flowing through z axis denoted as what? W. Denoted as W. Now let's give diagrammatically, let's see what it means. You have your diagram like this. You have your diagram, meaning you are representing the flow of fluid on your Cartesian coordinate. That's what we are saying. By diagram, you are representing the flow of fluid. You already know that there's a fluid flowing through x axis, right? There's a fluid flowing through z axis, and there's also a fluid flowing through what? Y axis. Now let's see it by diagram. By diagram, this is what we are saying. Say this is your z axis. Say this is your x axis. This is your y axis. Now from here, let's say you have a keyboard. Call this A, call this A, this is B, C, D, E, F, G, and H. Now earlier we said we are representing, this is our fluid, right? What we are just doing here, we are just representing what we've said now. From what we've explained so far, we are seeing the representation of our fluid on this Cartesian coordinate. Now you can relate this. Observe this dotted line. Observe this dotted line. It's the same thing as you saying your Cartesian coordinate, which is what? This is your y, right? This is your what? X, and this is your what? Z. Now, say from here, you can from D to H. Let's denote that what? You know, from D to H, we've said this is the x-axis, right?
Yes.
From D to C, this is the y-axis. Then from D to A, this is the what? Z-axis. So from here, let's say you have the x, you have what do you have here? The y, and A to D, what do you have? The z. Then we know that the velocity component flowing through x-axis is what?
U.
It is u, right? The velocity component flowing through y-axis is what? V. The velocity component flowing through z-axis is what? W. Now, this continuity equation in Cartesian coordinates is very simple as just solving. By the time you solve, you just verify if this particular equation is satisfied. If it is satisfied, it means if that equation is satisfied, it means continuity equation is met. I get what I'm saying. This thing is very simple. I just knowing that, okay, once this thing is being satisfied, then continuity equation has been what? Met. Now, mathematically, we are dealing with incompressible fluid. Mathematically, continuity equation is satisfied for an incompressible fluid if you have the partial derivative of u with respect to x. Do you know where this is coming from? For your x-axis, what do you have? U. The fluid component, which is this partial derivative of u, all divided by the x. This yes, what it means is that your x-axis, are you getting the point? The partial derivative of what? U, meaning the partial derivative of the fluid component with respect to that axis that you have the fluid component, plus the next one will be what? The partial derivative of v with respect to what? The partial derivative of y plus the partial derivative of what? W with respect to what? Z equals to 0. This interpretation, what it's saying is that for your x-axis, what's the fluid component? U. The axis where you have your fluid component to be u, what do you have there? X, meaning the partial derivative of u with respect to what? X. Similarly, the next one, what do you have? Partial derivative of u with respect to y. Where do you have your fluid component as v? The y-axis, this is it. With respect to that plane, this is it. Similarly to what? Partial derivative of w over the x. So what this means is that whenever you are given a question, and the question says that verify if this take note, this formula, call this one, equation 1 hold for incompressible flow. What did I say? Equation 1 hold for what? An incompressible flow. We also have for compressible flow, but we said earlier that we are dealing with what? Incompressible flow. What this means is that given any question to verify if your flow is incompressible, meaning once this equation is satisfied, what does it mean? Meaning the flow is what? Incompressible. But if it is not satisfied, meaning the flow is what? Not compressible. Meaning the flow is not an incompressible flow. So that's all the overall idea. That's it. So we are going to solve questions to see how this works.